Chapter 8, Lesson 3, Area of Composite Figures. A couple scenarios in which you would use the area of a composite figure would be, for example, if you had to calculate the amount of fabric when you're sewing a jacket from a pattern or any item of clothing, and also to calculate the amount of floor space when carpeting a room, when you're putting a carpet in. Those are just a couple of many, many examples in which you would use composite figures. A composite figure is made up of two or more shapes. To find the area of a composite figure, decompose the figure into shapes with areas you already know. Then you find the sum of those areas. So here are some area formulas that you have previously learned. The area of a parallelogram is base times height. The area of a triangle is 1/2 base times height. The area of a trapezoid is 1/2 height times the two bases added together. And the area of a circle is pi r squared. Another area that we just recently talked about is the area of a semicircle, which is area equals 1/2 pi r squared. And I also want to make a note in parallelogram, this also refers to rectangles. Rectangles are parallelograms. So here's an example of a parallelogram and a rectangle. Half of a circle is a semicircle, so here's a semicircle and a square. And here's a triangle and a trapezoid. These are composite figures. It's one figure, but you can decompose it into several different shapes, smaller shapes. And then what we do is we find the area of these smaller shapes. We already know the formulas for those, and then we add them together. So for letter A, find the area of the composite figure. Use 3.14 for pi. So what two shapes do you see? Good. I see a triangle. And I see a semicircle. The area formula for a triangle is area equals 1/2 base times height. Okay, so area equals, I'm going to use 0.5 for 1/2. The base is 11, and the height is 6. And what I'm focusing on here is this triangle. Use your calculator, plug in those values, 0.5 times 11 times 6, and you will get 33 meters squared. We'll worry about the units at the end. Now for the semicircle. When we use the area formula for the semicircle, area equals 1/2 pi r squared. Let me draw a line here. Area equals 0.5 times 3.14. You know what? I'm going to do this down here so I have a little bit more space. You should have space right next to it on your paper. Okay. Let's try that again. So we have our semicircle here. I'm just going to abbreviate. Area equals 1/2 pi r squared. Area equals 0.5. It says to use 3.14 for pi. And what's the radius? Be careful, it's not 6. What is 6? 6 is the diameter. So to find the radius is half the diameter. So the radius is half of 6, which means our radius is 3. So what we're plugging in here is 3. You have to be careful about that. When we are doing order of operations, we need to take care of our exponent first. 3 squared is 9. Bring down the other values. So we have 0.5 times 3.14 times 9. Type those in on your calculator, and you get an area of 14.13 meters squared. Now, we found the area of both pieces separately. So what we need to do now is we need to add those areas together. So we are going to add 14.13 plus 33. And make sure we line up those decimals. But of course, you can use a calculator on this problem. When you add them together, you would get an area of 47.13, and our unit is meters squared. Letter B. Find the area of the composite figure, round to the nearest tenth. Let's see how we can split up this figure. Okay, I see a way. We can draw a line here, which leaves us a rectangle down here, whose side length is 13 and whose base is 25. So we have a rectangle. Let's take care of that one first. Area equals base times height. Area equals 25 is the base of the rectangle. 13 is the height of the rectangle. Multiply those together. We get area equals 325 inches squared. What is this other shape you see? This shape is a trapezoid. A lot of times we forget about the trapezoid. Now this formula is a little bit tricky. Area equals 1/2 the height times base 1 plus base 2. So if you look at your trapezoid, this is your base 1, this is your base 2. They're the parallel lines. Okay? So base 1 is how big? Good, 25. Base 2 is 20. Okay? The height represents this short little distance here. Well, if I know this whole height is 20 and this little piece is 13, to find our missing height, we would subtract those two numbers. So our missing height is 7 inches. So in our formula, area equals 0.5 times 7 times our two bases added together. We need to take care of what's inside of the parentheses first. So bring down your 0.5, bring down 7, and let's add those together. 25 and 20 make 45. And now we can just multiply across. 0.5 times 7 times 45 is 157.5. Now that we have our two areas, we can add them together. So 325 plus 157.5. And we get a combined area of 482.5 inches squared. Area, squarea. When we're dealing with area, our units are squared. C. Pedro's father is building a shed. How many square feet of wood are needed to build the back of the shed below? So let's see here. We have a rectangle and we have a triangle. Let's find some missing lengths here. I have the lengths, the base and the height for my rectangle. I have the height for my triangle, but what's the base? Good, it's 15. It's just the same thing as the parallel line below it. Okay, so I have a rectangle. And I have a triangle. Start with the rectangle. Area equals base times height. Area equals base is 15. Height is 12. Multiply those together. You get 180. On our triangle, area equals 1/2 base times height. Area equals 0.5. Our base we discussed is 15. And the height of the triangle is 4. Multiply those together, and we get area equals 30. Now that we have the separate areas, what we need to do to find the total area is add them together. And we get a total area of 210 feet squared. That's a 0. That's supposed to be an F. There we go. 210 feet squared. To find the area of the shaded region, we're going to still use the areas that we know. Sometimes we will add, but sometimes we're going to have to subtract. Let's take a look at the first example. Now, we've got a rectangle. Okay, so let's start with that. Let's start simple. Let's take care of the rectangle area. Now, I know we're missing some spaces, but we'll take care of that in a moment. The rectangle, area equals base times height. Area equals, the base is 12. The height is 5. Area equals, well, 12 times 5 is 60. So I know the area of that big rectangle is 60 inches squared. And then what do you notice about these little corners? What shape is that? Good, they're triangles. So we have triangle as our other shape, and keep in mind we have 4 of them. Well, it has right in this corner the length and the width, or base and height, of our triangle. So area equals 1/2 base times height. Area equals 0.5 times a base of 1, a height of 1. Multiply those together, you get area equals 0.5. Now remember, we have 4 of them. So we need to take 0.5 and multiply it by 4 because we have 4 triangles. 0.5 times 4 is 2. So the area of just the triangles are 2. Now, it wants the area of the shaded region. The triangles are not shaded. In fact, it looks like this shape was a rectangle with the triangles taken out of it. So what we would do we would take the area of the rectangle and subtract the total area of the triangles, which will give us an area of 58 inches squared just for that blue shaded region. Letter B. The blueprint for a hotel swimming area is represented by the figure shown. The shaded area represents the pool. Find the area of the pool. Okay, so we actually have 2 rectangles here. Because we have 2 rectangles, I'm just going to label them Rectangle 1 and Rectangle 2. So let's find the area of rectangle 1. And rectangle 1 is this bigger rectangle here. Area equals base times height. Area equals 42 times 25. These are the dimensions of the bigger rectangle. Area equals 1,050. And that takes care of rectangle 1. Now we need to take care of rectangle 2. Same formula. Area equals base times height. This time, the base and height are along the edges of that white rectangle. So area equals 22 times 20. Area equals 440. So we have the areas of the two separate rectangles. Again, it looks like we have this big rectangle with this white rectangle cut out of it. So we would take the area of the bigger rectangle minus the area of the smaller rectangle, and we would get an area of 610 meters squared for just the blue region, or in this case, the swimming pool. Letter C. A diagram for a park is shown. The shaded area represents the picnic sections. Find the area of the picnic sections. So again, we're finding the area of the shaded region. Well, if I look at the shaded region, I see a rectangle, and I have the dimensions, length and width. So let's take care of that first. So the rectangle, area equals base times height. Area equals 60 times 25. Area equals 1,500. So that takes care of my rectangle. And I also have a triangle. However, I don't have any of the dimensions written for the triangle. This one's an easy dimension. It's the same length as this over here. So I know that this height is 50. Okay. But I have to find this length right here. I know this entire length is 150, and this little piece of it is 120. So to find this area, or this length, I should say, we would take 150 minus 120, and that distance or base is 30. So our formula, area equals 1/2 base times height. Area equals 0.5. The base is 30 and the height is 50. Area equals 750. Now what we did is we found the areas of both those shaded regions. We didn't find the area of any white space. So all we have to do in this case is we're back to adding, because we just found the areas of the shaded region, so we add them together. 1,500 plus 750 is 2,250 yards squared. So when you're finding the area of your smaller figures, If you're finding the area of everything shaded, you add them together, like in this example. If I glance back at B, what I had to do was I found the area of the shaded region, then I found the area of the white space, so I had to subtract. And here again, I found the area of the shaded and the area of the white space, so again I had to subtract. And that is lesson 3. Yeah.